We're recording. I was told to wait until I hit record to open this so that like the reaction can be, preserved for posterity. Let's see. Oh no. My challenge coin. My very own. Thank you. This is going in the office. Thank you very much. I appreciate this. This is my my challenge coin that she created. It's got, I guess I'm the king of dad jokes. Behind me is a samurai sword and lightsaber. So yeah, in case I'm a sci-fi fan. So thank you. This is going in the office. I appreciate this. Even the evil twin made it on here. This is awesome. Thank you. I appreciate that.
Did you pass the mistake challenge?
Says 7, but again, since I'm the one that reports it to the university, it's a corrupt system because it'll never hit 7. I know it's corrupt. All right, all right. Let's get this final lecture started. Lecture 41, our last time meeting in class for CE 312. Although we do have our exam next Monday in 3 days. So a couple of housekeeping items. So my TA has started to chip away at the remaining homework assignments. So 8.2 and 8.3 are graded. That's backwards. So maybe I finally hit 7 because the first one, these are graded. Oh, these are graded, and these are being graded.
You're lucky. That's number 6.
That's number 6. All right, yeah. So, but yeah, everything up to 8.3 is graded. There's 8.4, 8.5, and 9.1 that are outstanding, along with 9.2, but you literally just turn that in. Now, remember 9.2, I'm not accepting any late submissions because if you look on Blackboard right now, you will see the solution to homework 9.2. So every single homework assignment in this course, the homework solution is available on Blackboard. Every one, okay? So don't forget the bonus assignment if you haven't already done that. I have no idea who's done it through the university system. Like I can go onto MyMU and all it tells me is how many people have done it. But the number of people that have done it matches the number of people that uploaded proof to Course Eval. And I've got 3 people in here that haven't done their survey. So if you haven't done it, do so. Free homework points, etc. Okay, let's talk about exam 3, which is the final exam, although it is not comprehensive. It's just going to be on everything since exam 2. In terms of the delivery, it's going to be very similar to what I've done to previous exams. This is another exam like any other. So I know that the university gives us 2 hours, but I'm only going to craft the exam as if it's a regular 50-minute exam. So it's going to be any exam like any other. And for this course, I've always done that. One of the things I'll tell you, and I'll be honest, I'm not 100% sure yet how I want to do it, whether or not I do it by paper or I do another thing on Blackboard, but I'm also going to give you that CLO survey, where you rank the outcomes in the class on a scale of 1 to 5, like how well can you solve trusses and whatnot. I'm sure you've done that before in other courses. So I don't know if I'm going to do that on Blackboard or if I'm going to do that on paper, like I just hand it out. But regardless, I'll set it up in such a way that I don't know who wrote what. I know that on Blackboard, you can set up certain questions to where they're randomized for the evaluator, so I have no idea who did what. But the one thing I have to do is I have to make sure that I'm separating those of you that are BSc students and those that are BSCE students. That's like the most important part for me from a accreditation standpoint. So I will also probably, so that survey will have questions that are just going to be you on a scale of 1 to 5, ranking how you think the outcomes in the course were met. But I will probably come up with some additional questions to ask you about the CAD project because that was kind of new. And I really would like to get your feedback on what you thought of it. And if you have any suggestions for how the project should improve in the future, I'd really appreciate that. But again, the exam's only going to be designed to be like a 50-minute long exam, even though you have 120 minutes to do it. So historically, when I've given this exam, most people are well finished before the 2 hours. This is definitely not a time crunch exam. The format, though, in terms of what you're allowed to use, what the exam looks like, it's pretty much going to be all the same. Like if you've had exams with me before, it's not going to be any different. Open book, open notes. You can use any resource on Blackboard. You just cannot use another person. So no forums, no Chegg, none of that. But you've got the lecture notes, you've got the solutions to all the homeworks, you've got the recordings. You can even pull those up. You can pull up the OneNote that has all the calculations, all of that. I have no problem with that. It will contain 4 to 5 conceptual questions, and it will contain 3 computational problems. I'm going to go ahead and tell you one of the problems is going to be a Mastan related problem, but it's not going to be one where you have to use the software. It's basically going to be one, and I don't want to reveal too much about it, but it's basically going to be one where you look at the structure and you're going to have to answer certain questions about how you would model it. For example, things like how many joints would you use for this structure, and I might have you compute some values associated with that. If you remember, there are certain things that you have to account for when you use Mastan, things like common coordinate systems, things like consistent units, stuff like that. So if you understand how to use Mastan, which hopefully by now everybody has a good enough experience set for that you should be fine. I mean, we've had the in-class exercises, we had the homework assignment, we had the projects. You all have enough experience with that I think you're going to be just fine with that. Let's talk, though, about what topics are on the exam, and then I'll open it up for questions. So really the 3 big stars on the exam are influence lines. That's probably the biggest topic that we covered since exam 2. So you have to be able to draw an influence line for a given response at a given point. So a vertical support reaction, shears and moments at a given support, or at a given point, fixed supports. I will not make you do a truss influence line. I'll go ahead and tell you that. I'm not going to do that. I don't think it's hard or conceptually difficult, or either computationally or conceptually difficult, but I do think truss influence lines are time crunchers. They just take a lot of time, and I'm not into doing that on your final when I could test you on the concepts and the computations just as easily with some shorter problems, like with beams and what have you. Be able to utilize those influence lines to determine response. This was like homework 8.4 and 8.5, and be able to utilize the envelope responses due to transient loadings. This was like 8.4, this was like 8.5, so in terms of the homework assignments. For computer analysis, basically be able to demonstrate a general understanding. Pre-processing is really what I'm most interested in, your ability to understand how a model is crafted, or how a model file is generated. I'm not concerned too much with your ability to post-process because I'm not going to make you run Mastan, okay? But you do need to understand the basics of Mastan operations. So remember, there are 5 modules that you utilize in Mastan. There's the geometry model, where you're crafting the nodes and the elements and the connections. There's the properties module, where you're defining and attaching materials and section properties. There's the conditions module. Conditions is where you apply boundary conditions, apply loads, etc. You analyze the structure, and then you post-process the results. And the final topics on the exams are what we've been talking about this week. So be able to utilize and or derive analysis aids in performing basic structural analysis. This was like homework 9.1. This was homework 9.2. Be able to demonstrate an understanding of tributary width or tributary area. And as you know, for the exam review PowerPoints, which this is on Blackboard right now, so everybody has this, I like to give you a one-stop shop. So this is all the greatest hits, if you will, the formulas necessary for what's going to be on the exam. So influence lines, make sure that you can plot those for reactions. So these are sort of the rules for drawing influence lines for reactions. These are the rules for drawing influence lines for internal shears and moments. So remember, with moments, we say that this slope plus this slope equals 1, so that slope plus that slope equals 1, and then we recognize that the unknown is the height, and so we can solve for that height pretty easily. For shears, we know that this slope and this slope are equal, and this height plus this height summed together equal 1. So it's sort of a two equations, two unknown standpoint, but we can, again, it's not too challenging. Oh, for shears and moments, also don't forget that whenever you're drawing an influence line for internal shear, internal moment, those influence lines always equal 0 at the supports, because if you put a load at the support, there's nothing going on inside the structure. For matrix analysis, this is sort of the flow chart of what Masthead's doing in the background. So what you do as the user are the two blue boxes. You pre-process, and so that's the geometry, the conditions, and the properties. Those are those three menus. And then the analysis button is this is what Masthead is doing during the analysis, and this is the results. So, remember, I discussed this during the first Masthead lecture, but basically what Masthead is doing is it's writing a stiffness matrix for every member, every element in the model. It's assembling them. It's knocking out the rows and columns associated with the boundary conditions, and there's your stiffness matrix. And then it does the same thing with the forces, and then it says, I got the forces, got the stiffness matrix. It solves for the displacements. Then it takes those displacements, back substitutes them in to get all the forces in the members and the reactions, et cetera. And that's kind of how matrix analysis works. That's the 30-second version. If you're ever interested, there's a course called finite element analysis where you go through that. That's like the whole purpose of that class, is to understand computer analysis of structures. It's a really, really good class. For the fundamentals of matrix analysis, this is like the sort of the key stuff that you kind of need to understand when you start building a model. So you remember the terminology. The terms joint and node are going to be used interchangeably, just like the terms member and element. When it comes to units, whether the software program does this for you or you as the analyst need to do this, all the units need to be consistent. So all the forces need to be in a consistent unit system, and all the lengths need to be in a consistent unit system. What we typically do is as analysts, we ask ourselves, what do we want the deflections to come out as? And then that's our length unit. So in US units, we typically express the lengths in inches because we want our deflections to be in inches. And in metric, we take our lengths and express them in millimeters. So you might have a beam that's 2,000 millimeters long, something crazy like that. But we do that because we want the deflections in millimeters. As for the forces, we typically use a larger force unit like kips or kilonewtons. We could use pounds, but then our number, they get really big. We have really, really big numbers. So that kips are a little bit more convenient. For sign conventions, make sure that you recognize that forces and displacements to the right are positive, forces and displacements upward are positive, counterclockwise moments and rotations are positive, and typically axial forces, tensile forces are positive. You can actually change some of this stuff inside Masthead. You can also do things like flip the moment diagram upside down. We never did that, and most analysts don't, but you can. Let's see, what else? Okay, defining a Masthead model. Remember, these were the 5 menus, and if you go through those menus sequentially and define everything you need to define, Masthead will work just fine. Geometry, properties, conditions, analysis, and results. This is just me giving you definitions for nodes and elements. Nodes are where the software will directly compute the deformations. And so in matrix analysis, you compute the deformations directly at the nodes, and you linearly interpolate everywhere else. Or not necessarily linearly interpolate, but you interpolate everywhere else. And so generally for civil engineering structures, you should put nodes at support locations, internal hinges, truss joints, locations of point loads, although that's not totally necessary for given structural analysis packages, but for Masthead it is. At other points of interest, if you want a deflection at a given point, put a node there. Elements, the way matrix analysis works is it writes a stiffness matrix for each element and then assembles that into a stiffness matrix for the whole system. So the model is broken down into these discrete solution regions called elements. And for linear elastic analysis, which is what we do in this course, we just use one element per member. When we're doing geometry definition in mass stand, we have to use a consistent origin. Remember, we looked at this 100-inch long beam, and we said any of these coordinates would be fine in defining the length of the beam, because as long as your origin is consistent, what mass stand is going to do is take the difference between the coordinates and recognize that that's a 100-inch long beam. Tributary area, this is really sort of the last thing that I think is unique. We did have analysis aids, but I don't really think analysis aids are adding anything to the conceptual discussion because we're just using math to derive equations for shears and moments and whatnot. But tributary area, maybe that should be formally defined, that that's the loaded area that contributes directly to a member. It is typically defined as halfway over between adjacent elements. We use those to perform load takedowns. That's right, I have ink annotations because I had a typo on the first slide. All right, that is the exam. That's what's on exam 3. I'm going to shut up for a second and entertain questions from the people in this room. The floor is yours. Ready for the semester to be over? Well, we're almost there. We're almost there. I know it's been a transition, you know. Yes?
As far as like analysis aids go, I don't know, was there a slide where those were like provided, or would those be allowed on the exam if we would benefit from them?
That's a good question. What I will tell you, without revealing too much, is that there will be no useful analysis aids beyond what's already been provided. So by that I mean homework 9.1 and what we did in the example will largely be all that you need. And here's why I don't provide a big list of them, which, by the way, you could Google them and find them right now. But the reason why I don't provide them is because I don't want to, if you download a set of analysis aids right now, there's like 50, 60 of them. And you got to sift through a bunch of them to find the one you need. When I'm telling you, you're only going to need 1 or 2 of them. That's why I don't want to say, oh, here's this, massive pile of stuff, good luck. You don't need it. I'm not going to expect that you need more than are already currently available to you. So they're not needed. Now, when you open up the steel manual, there's a ton of them in there, but you know where they are anyways. And in that course in steel design, we spend a lot more time with them, so they're not as daunting as they would be if I threw 50 sets of equations at you and said good luck. So I won't throw anything crazy at you, I promise. How's everybody feeling about the exam? Is there anything about the exam that's making you nervous? Anything that's you feel comfortable? That's a good sign, I would think.
I guess the only thing I would have to look at is our last homework problem.
The tributary area?
Yeah, I feel like every time we have an exam, I get the last topic that we just went over.
That's the one that gets you?
Yeah.
Well, fortunately, I think that for this exam, that's the easiest topic. And I say that because that hasn't always been the case in here. For example, in exam 1, the very last topic before the exam was truss deflections, which is the most involved truss analysis you can do because you have to do it twice. And then for beams, it was the same story. For exam 2, we had beam and frame deflections was the last thing that we covered before the exam. So for this, it's not true. I would argue 8.5 is probably one of the most challenging homework assignments because that was the one with the truck, the lane, and the tandem, and so you had to draw the influence line, and it was a lot of plug and chug work, and that was maybe the only downside is that was before break. So Does anybody have any questions, let's say, about influence lines, about mass stand? You tell me. Before we call it, do you all want to end class early, or do you have anything you want me to cover? It's up to you. Yes.
With mass stand, I feel like with most of the information, say we might need, would at least like most of it be like within the jar, like most of the conceptual information we might need.
Yes. Yes. It's all there. I'm not asking you anything esoteric, anything out there. I'm not. Everybody feeling good? All right. We're not going to end just yet, but in terms of questions on the exam, going once, going twice. Okay. A couple final housekeeping items, and then we'll close it. So again, we're going to get the homeworks graded as soon as possible. You might have some homework grades trickling in during finals week. My TA was taking some graduate courses this semester, and I know she got kind of slammed near the end. So, but she's chipping away at the outstanding assignments. If you have yet to do the bonus assignment, please do. Again, you can say I'm the worst professor ever, but if there is any suggestions that you have for future offerings, I do mean it. That I do take that step pretty seriously. And finally, this is the last time that we'll meet before you take me for seal design next semester, if you choose to do so. One thing that I think is worth mentioning is that I know that everybody is, I would say probably the vast majority of you prefer being here in person, right? We're not back to virtual land, but I also recognize that even though we're back to in person, it has been a weird, time, and whatnot. And also, we are, even though we're in person now, you weren't last year, And last year you had statics, dynamics, mechanics of materials, a lot of stuff that we use in here, And so I do appreciate that even though we're back in person, but that because of the previous material that this course hinges on, no pun intended, it was my last chance. But because of the previous material that this course relies upon, that there might have been some challenges that, in normal scenarios, students might not have had. You know what I mean? Like, and I'm going to say this to you. I'm definitely going to say it to my statics course this semester, because these folks were having calculus online, and now they're, in statics. And so I do want to say that hopefully the worst of the pandemic is behind us, but I will say what I said at the end of statics and all my online classes last semester. I'll say it to you all again. I'm proud of each and every one of you. I think that you had a much more trying college experience than I had, than any of your professors had. We didn't have to go through this crap. We didn't have to go to class and last year have online classes and then wear masks every day in class. We didn't have to deal with all that, and you do. So that sucks. It does. But you've handled it well. One of the things I have noticed about the engineering students that I have interacted with is that I know I know this has been some weird and trying times, but I haven't really heard anybody really complain, not really. You all have knuckled down and gotten it done, and I really appreciate that, and I'm proud of each and every one of you. I will see you all on Monday. That's all I got. And thank you for the challenge coin.